All right, so on the rational equation worksheet, let's kind of go over what the main idea if I'm going to solve a rational equation. All right, we'll do 44. Okay. So I want to get rid of the fractions, right? Okay. Now, so we can multiply through by the common denominator to get that done. Okay. But one of the things that the directions prompt you for is that every solution that you get, even though you may work it out correctly, is not a correct solution, is it? Okay. Sometimes you get a solution that would be extraneous. Okay. And so that's why they say on part A to write the values of the variable that make the denominator 0, because if you get one of those answers, then it's really not a solution, and you have to say that, well, there's no solutions. Okay. So all right, we'll look at 44. 3 over x plus 3 equals 5 over 2x plus 6 plus 1 over x minus 2. Okay. Now, this one was pretty ugly when it worked out. All right. So you didn't really you had a lot of factors, I think, in the common denominator here. Now, first off, that 2x plus 6. That would be what? 2 times x plus 3. Okay. So now, let's talk about our common denominator. Now, notice, in that one, you have the 2 is called a monomial factor, right? So that's the only monomial factor that you have, isn't it? All right, so we'll have 2. Okay. All right, what else am I going to have in my common denominator? Okay. 2, we said that one. X plus 3 and x minus 2. Okay, so we're going to multiply everything by 2 times x plus 3 times x minus 2. And this was the only one where you had such a big common denominator. Okay, it had like 3 terms in it there. 2 times x plus 3 times x minus 2. Dang, I need to be like, if I was like 1.5 inches taller, the smart board would be perfect. But I can't quite reach the top of it. Well, I don't know how you did that. Okay. All right. Now let's go to canceling. Okay. So x plus 3 is going to cancel out for me. But now, a lot of times what you're left where you just have to multiply something that's fairly simple. Well, now I have to multiply 3 times 2 times x minus 2. So I'm multiplying 3 things. Now, the order that you do it doesn't matter. So I'm going to suggest this. Let's multiply 3 times 2 first. Y'all with me there? And so 3 times 2 would give you 6. And now let's say 6 times x minus 2 would be 6x minus 12. All right, did y'all follow me okay there? Okay, no? All right, go back. So let's do 3 times 2 there would give me 6. And so I'm going to say 6. So what you can do if you want to do this, that might help you, okay? And then you can visually see it. All right, 6 times x minus 2, now you probably see it, right? 6x minus 12. All right, the next one's not too bad. 2's cancel. X plus 3's cancel. And so that's going to leave you 5 times x minus 2, so that would be 5x minus 10. All right, and on the last one, x minus 2 cancels. Okay, so you're left with 1 times 2 times x plus 3. So 1 times 2 would just be 2. And 2 times x plus 3 would be 2x plus 6. Okay. Now, if you make it here correctly, chances are, you're going to get it from here. Okay. It's probably just getting it to that point. All right, y'all finding like a mistake or something somewhere when you're doing that one? If you missed it? Okay. Now, I forgot to do part A, didn't I? Let's go back. Let me do part A right here. Part A said what? Yeah, what do we have to restrict? X cannot be, yeah, 2 and -3. Okay. All right. So if I get 2 or -3 as a solution, it's right, it's wrong. There would be a no solution if that's the case. All right, let's see what we get. Now, I'm going to combine some terms on the right side there. So that will give me 7x minus 4. All right. Now, I'm going to put my variables on the right sides. I'll subtract 6x from both sides. This is going to give me x. Then I'm going to add 4. So that'll give me -8. Okay. Now, is -8 okay? Yeah, it's not 2 and it's not -3. So that's an okay solution. All right. 46. Okay. All right. Now 46, it's sort of already factored for you. If I'd have wrote this problem like in the textbook, I would have wrote it like this and made you figure out how to factor that. Okay. They didn't really do that. They just had x minus 2 times x plus 2. Okay, so it's just binomial factors. So what do we have for our common denominator? We've got x minus 2, x plus 2, both common factors and no leftover factors. So x plus 2, oh yeah, we forgot about that part. X cannot be plus or minus 2. Okay, now let's multiply by that common denominator. Now, let me ask you guys this. Do a lot of you skip that step where you're not writing them all out? I mean, do y'all skip like writing out x plus 2, x minus 2, x plus 2? You do? You write it out? Okay. And once you do a lot of these, you might try to, if you're like trying to do it faster, actually skipping that step. Okay. I'll show you a shortcut to this in just a minute. Now, let's go to canceling. So those will cancel. So 5 times x minus 2 would be 5x minus 10. Okay. Those will cancel. So give me 3 times x plus 2 would be 3x plus 6. And now both of them cancel there. Right, so it's just 12. Okay. And so there again, if you make it here, okay, then you're good. Yes. Yeah, let me finish this one. Okay. All right, this will give me what? 8x minus 4 equals 12. And then we're going to add 4. So that will give me 16. 16 divided by 4, not 4, divided by 8 is 2. So is 2 okay? No. X cannot be positive or -2. In this case, it can't be that positive 2. Why not? Well, that makes me divide by 0. Okay? So what are we going to do? Because if I leave this, it's wrong. Yeah, no solution. And I want to probably want to mark that out or erase it even. Okay? And say, really, there's no solution there. That's an extraneous solution. Okay. All right, so number 40. Okay. Now, while I'm writing this one down, let me ask you this. Do y'all find that that these are easier than adding and subtracting? I mean, that's really what I get out of this. Okay, I will. I mean, is this easier than adding and subtracting these? Yeah, okay. Because what? Once you get that first initial thing where you get rid of the fractions, it's over. Okay. All right. We'll have to go back over that today, so that's okay. Now, so let's see. What about part A here? What x cannot be? We got to restrict. X cannot be -4. Okay. Now let's solve it for part B. Now, but there's only one thing in the denominator here. It's just x plus 4. So the common denominator is going to be x plus 4. Okay. Now maybe what you might have done wrong on this one is you might have forgot that you still have to do -7 times x plus 4. So be sure that you did that. To me, that would be like a common mistake that I'd see if I was grading papers. Now, that'll cancel, so that's just going to leave me 3. Now, let's do -7 times x plus 4. That would be -7x minus 28. Maybe another mistake you made was maybe that sign right there, okay, because it's -7 times that. All right, and then these cancel, and so that's just -4. Okay, all right, let's clean it up. 3 minus 28 would be -25. All right, I'm going to add 25 over to both sides. So give me 21. So 21 divided by -7 would be -3. Okay, now -3 is okay. -4 wouldn't be okay, but -3 is okay. Okay, all right, which other one did y'all say? 34 and 28, okay. Let me see, where's 28? All right, now 28, you didn't have to do the restrictions. Let's kind of look why. Notice there's no variables in the denominator. That's why you didn't have to worry about it on this problem. Okay, you just solved this one. So again, we're going to multiply by our common denominator. Well, now we've got 3 and 8. So 24 is our common denominator. Okay, so let's multiply everything by 24. I want to need some help. What's 24 times 5? Okay, thank you. All right, and then what? 3 goes into 24 8 times. Now we got to multiply 8 times x minus 2, and you got to be sure to distribute. It would be 8x minus 16. All right, and then 8 goes into 24 3 times. That's going to leave me with 3x plus 9. All right, now let's clean it up and solve it. I'm going to do 120 minus 16 is 104. All right, and I'm going to subtract 3x from both sides. That's going to give me 5x. I'll subtract 104 from both sides. Negative 95. Is that right? All right. And then negative 95 divided by 5 would be negative 24. No. Yeah. Sorry. There we go. That's it. All right. What was the other one? 32? 34. Okay. All right. We got 7 over 2x minus 5 over 3x equals 22 over 3. Now, we got to go back to restrictions because we got variables in the denominator. Tell me here x cannot be 0. Okay. Now let's talk about our common denominator. We've got a 2, a 3, and a 3. So the number part would be 6. Okay. And then right, 6x. Okay. Because we got the x there. So we'll multiply by 6x. Okay. Let's go to canceling. And usually, let me make a comment here. I think one of the reasons you might struggle with this is in middle school, they don't teach you guys how to cancel like they should. Okay? Like for instance, I'm on my soapbox here a little bit, okay? Just making up random stuff. Okay? That doesn't really turn out too good. But anyway, when they teach you guys to multiply fractions, they taught you to say 2 times 12 is 24 and 3 times 8 is 24, didn't they? Okay? And really, they should not be teaching you how to do fractions this way. If I'm multiplying, I can cancel out, right? Okay? What? 2 goes into 8 4 times. 3 goes into 12 4 times. And what? 4 goes into 4 1 time, and that's 1. Okay? They don't show you how to do that. And that's why y'all struggle so much with this usually. Okay? It's your middle school teacher's fault. It's not my fault. Okay? They didn't teach y'all how to cancel with fractions. And I ask middle school teachers, I say, well, how come y'all don't teach them how to cancel? Well, they don't understand. How could you not understand how to cancel? If you can reduce a fraction, then you should be able to cancel a fraction. Okay? Yeah. Well, here's the idea. They don't see the long-term picture. They don't see this coming up. And so they just take the easy way out. Okay? All right. I'm going to get off my soapbox now. All right. Let's do this. Now let's go to canceling. Okay? Oh, yeah. Thank you. We do need to do that. Okay? Because if we don't do that, we won't think of that as being a -5. All right. Now, x's cancel. All right. What? 2 goes into 6 3 times. This would be 3 times 7 is 21. Okay. X's cancel again. 3 goes into 6 2 times. So that's really going to be, yeah, -10. All right. 3 goes into 6 2 times. So 2x times 22 would be 44x. All right. So now we get what? 11 equals 44x. And we're going to divide by 44. So that would reduce to a fourth. Okay. All right. Did y'all say like we can do like one more? Yeah. 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 On 48, your common denominator is x plus 5 times x minus 5. Okay. On 50, your common denominator ends up being x plus 3 times x minus 2. And be sure on 50 that you don't subtract, but you add the opposite on that one, okay? All right. Now, let's look. Find my new one here. That's not what I wanted. All right, look at what I gave you here, this worksheet, okay? Now, we just finished here. We just talked about rational equations, all right? So the next progression here is to talk about rational inequalities. So inequalities, we're talking about greater than, less than, greater than or equal to, less than or equal to. Now, the way we solve these is completely different. You know, most of the time when you solve an inequality, it's really not that different. Like, let me give you an example here, okay? If I solve, say, 2x minus 3 equals 13, and let me just make that negative right there, okay? Versus negative 2x minus 3 is like greater than 13, okay? Is there really a big difference in the process? No, okay? There's only one difference in that inequality version, okay? What is it? Right, right. If you, now listen, if you divide by negative, and really in the truth, if you multiply by negative, you have to flip the inequality sign. So you see in that second inequality there, on the second one, eventually you would have to switch that to less than, okay? Now, other than that, there's really no difference in solving a plain old equation versus a plain old inequality, but these aren't plain ones. These are rational ones, okay? So the strategy that we use to solve equations is not going to work with solving inequalities, all right? Here's why. Our strategy in solving equations is to multiply through by the common denominator, okay? Now, let's see if you can figure out what would be wrong. I'm going to do 43 in just a second. If I tried to multiply by x plus 3 on both sides, okay? It's not the zero thing. All right? You remember what I said? That what we can't, if we multiply or divide by a negative, then we have to flip the sign. All right? Is x plus 3 positive or negative? Well, we don't know. Okay? So here's the thing. When I multiply both sides by x plus 3, it's unclear whether or not I need to change my sign because I don't know if that's positive or negative, do I? So that makes me change my entire strategy when I solve an inequality one. Okay, so let me give you the steps here to solving this one. I'm going to work a lot of the odds, just like we did yesterday, and I'll give you not all the evens, but some of the even ones, okay? Y'all can circle the ones over there, 44, 48, 50, 54, 56, 58, 60, okay? Now, all right, let's look at this one now. Let me give you some steps here to go by, okay? Now, this first step's not going to apply in this one, all right? The first one is set it to 0. That's pretty much already done there, isn't it? Okay. All right. Next step. Okay. You're going to add or subtract, whatever the case is, to make a single fraction. Okay. Add or subtract to make a single fraction. Now, look at this one. That's already a single fraction. Okay. So what I'm talking about is if I had something like this, I would need to add that together to get a single fraction. Now, if I'm going to add something like that together, I need a common denominator, don't I? Okay, so we'll look at that on the later examples here, okay? But that's already a single fraction, and most of them are going to be like that. Now, here's where it gets kind of crazy, all right? The third thing is you figure out what makes the numerator and denominator 0. Okay, now let's go ahead and do that. All right, so what makes the numerator and the denominator 0? All right, you have 4 and -3. Okay, now, so what we're going to do from there, we'll plot that on a number line. Okay, so plot those on a number line. Okay, now let's do that. So +4 and -3, right? All right. So -3 would be on the left side, +4 would be on the right side. Now, here's where it gets a little crazy, and these are not really fun problems. They're not very hard, but they're real tedious. Okay. The next thing, what you do here is you test intervals for the solution. Okay, so when I say test intervals, I mean test intervals on the number line. Test the intervals for the solution. All right, now to kind of make this a little bit more organized, what I do is I name my intervals. Yeah, that's pretty much the last thing. Now everything else is just going to be work. Okay, I really can't put it into a step form for you. So when I plot these values on my number line, -3 and 4, it breaks the number line up into 3 intervals. You know, kind of see that? Like numbers that are to the left of -3, numbers that are in between the two numbers, and then numbers that are bigger than 4. Okay? So what I do is I kind of label the intervals. All right, so I call this interval A, interval B, and interval C. Okay? Now, what I do to figure out if those intervals are, are part of the solution to the inequality is I test a value in that interval. Okay, so what would be a value that I can do in interval A? What would be a number over there? -4, right? Would -4 be in that interval? -2 would be in interval B, wouldn't it? Okay, so I'm going to test here -4. Now, so what I'm going to do is I'm going to plug in -4 into my inequality and see if it's true or if it's false. And when I plug it in, I don't really necessarily have to get numbers. All I have to do is get signs. Okay, let me show you what I'm talking about. So let's plug in -4. So if you plugged in -4 right there, -4 minus 4 would be what? -8. Okay, now don't worry about saying -8. Just write negative. Okay? When I plug it in, it makes the numerator negative. Now, what would happen if I plugged it into the denominator? -4 plus 3 would be -1, and that will give me a negative, right? And so we got a negative over a negative is greater than 0. Now, a negative over a negative is positive. Now, do y'all see why we're only doing the signs? Because if we're talking about 0, if you're greater than 0, you're positive. If you're less than 0, you're negative. So that's all you have to really do. You don't actually need the number. You just need to know if it's positive or negative to see if it's true. So is a positive greater than 0? Yes. Okay. So this part is true. So since this is true, interval A is a part of the solution. So on my number line, I'm going to color in interval A. Now, what do you think I'm going to do at the value of -3, seeing how this says greater than and not greater than or equal to? What kind of open circle? Okay. All right. So because it just says greater than and not greater than or equal to. Okay. If it would have had equal to there, then we'd put a closed circle. Now, let's test interval B. Okay. So, y'all, what would be a value in interval B here? All right, -2. 0 would be very easy to test. Wouldn't you agree? You know, I always like to choose 0 if I can. So, all right, in interval B, I'm going to erase this right here, okay? Now, that's something that you would keep on your paper, okay? I'm just erasing it for the sake of having room. All right, so for interval B, we're saying a number that's in interval B would be 0. Okay, now let's plug in 0. So if I plugged in 0 here to the numerator, I get 0 minus -4. And don't tell me what it would be. Just tell me, would it be positive or negative? It would be negative. Okay? And then in my denominator, 0 plus 3 would be positive. Okay? Because 0 is in interval B. Okay? You understand there? Because 0 would be in between -3 and 4. So there's lots of numbers you could use right there. You could use like 1, 2, 3, lots of numbers. Now, so I get a negative divided by a positive. Now, negative divided by a positive would be a negative, wouldn't it? Okay, so we'd have a negative is greater than 0. Now, is that true? No. So that means the numbers that are in interval B are not solutions. Okay, so we're not going to like shade in interval B. We only shade in the ones that make it true, which is the ones that are the solutions. Okay, now let's do interval C. So what's a value I could put in interval C? Yeah, 5. Okay, 5 would work pretty good. So C, you can use 5, 6, 7, what have you. All right, now let's plug in 5. So if you put in 5 to the numerator, 5 minus 4 would be positive. Okay, 5 plus 3 would be positive. Okay, so positive divided by positive is a positive. So is a positive number greater than 0? Yes. Okay, so interval C is a part of the solution. Okay, now what about 4 itself? And keep in mind that that was greater than. So write open circle. Right. Now there's an exception. I know y'all think that greater than or equal to would mean a closed circle. There's going to be something that'll come up where sometimes it wouldn't actually be. Okay, let me go ahead and explain that. Let's change it. Are we okay so far? All right. Right. Here's the thing. All right, what if it did say, let's change the problem to say greater than or equal to 0. Okay, so you would probably think that means, okay, that means I would include -3 and 4, so I would do them with closed circles. Okay, now you would do that with 4, but you couldn't do it with -3 because it would make it undefined, would it? Okay, you can never include anything. In other words, you can't have a closed circle on anything that would make you divide by 0. So that would look like this. We could close up the 4, but we could never close in -3 because that makes it undefined. Even though this says greater than or equal to, can't do it. Okay, can't include anything that would make it undefined. Now, let's look back. I kind of skipped over reading the directions, which is not a good thing. Okay, all right. It said to solve each inequality and graph the solution set on a real number line. Now we did that. Okay, that was part of the process. Express each solution in interval notation. So we're going to put this in interval notation. All right, let's write it in interval notation. How we do that? Parenthesis, -infinity to what? -3, parenthesis because it's open, and then what? Union, bracket, 4 to infinity. Oh, okay. Well, if it was greater than or equal to, we would do it. All right. So we want to change it back. Okay. So if we change it back, that's going to be open. And then this would be parenthesis. Okay. I'll do this for you. All right. Now, y'all see how it's not really hard, but testing all the points is pretty tedious. Okay. Now, let's look. I think we'll skip over this one for time's sake here. Okay. I think that will do okay on that one. Yeah, here we go. Okay. Let's look at this one. So this one's even going to be more tedious here because, well, notice, all right, first off, is it set to 0? All right. Is it a single fraction? Yeah. It's just one big fraction. Okay. We'll look at one later that's not like that. So all we have to do is come up with the critical points. Okay. The values that make the numerator 0 and the denominator 0. So that would be what here? -4, 1, and -2. Now we've got to be sure to put them in the right order on our number line. So the one that would be to the most left would be -4, and then -2, and then 1. Okay, so now look at this one. This one's going to be real fun. Look how many intervals we're going to have to test here. Yeah, 4 intervals. Okay, so I'm going to label. I got A, B, C, and D. All right, now let's plug in some numbers from those intervals and let's see which one's going to work and which ones aren't. So, all right, guys, so give me an idea of what could I plug in for the A interval? At -5. Okay, so let's put in -5. All right, -5 plus 4 would be negative. Okay, and remember, you don't have to do the number, you just do the sign. Because it would be an interval A. Okay, and then, all right, what about -5 minus 1? That would also be negative, right? All right, so I got a negative times a negative in the numerator. Now, -4 plus 2 would be a negative. Okay, so we got all negatives here, less than or equal to 0. All right, so what's this going to turn out to be? All right, a negative times a negative would be a positive, and then a positive divided by a negative would be a negative. Okay, now, is a negative going to be less than or equal to 0? Yes. All right, so is interval A a part of the solution then? Yes. My question? Well, what I said -4. Yeah, yeah, I did say that. Yeah, I meant -5. All right. Now, so interval A works. So we're going to shade in interval A. Okay. Now, let's talk about whether or not to include -4. Okay. Now, it says what, less than or equal to. But I got to be sure now, would -4 make it undefined? No. So, no, let me ask you this. No matter what kind of symbol I have right there, what's a number I'm never going to include on this number line? Yeah, -2, because that makes it undefined. Even though it says less than or equal to 0, I can't include -2 because -2 would make it undefined. Okay. Now, so let's go to interval B. All right. So guys, what's something we can test in interval B? Yeah, -3. Okay. All right. So let's see. Let's plug in -3. -3 plus 4 would be a positive. Okay. -3 minus 1 would be a negative. And then -3 plus 2 would be a negative. Okay. Now, let's see. All right. Is that less than or equal to 0? Well, let's do what a positive times a negative in the numerator would be a negative, and a negative divided by negative would be a positive. All right. So is a positive less than or equal to 0? No. Okay. So interval B is not a solution, is it? So we'll skip over interval B. All right, let's go to interval C. Move this down. All right, yeah, 0 would be a good one to check for C. Okay. All right, so let's plug it in the numerator. 0 plus 4 would be positive. 0 minus 1 would be negative. And then 0 plus 2 would be positive. Okay. Now let's see if that's less than or equal to 0. So a positive times a negative would be a negative, and a negative divided by a positive would be a negative. All right, yeah. Okay, all right, go back. Look, a positive times a negative is a negative, and then a negative divided by negative is a positive. All right, now y'all see how on part C that this is going to give me a negative right there? Okay, so this would be negative. Now, so is a negative less than or equal to 0? Yes. All right, so we got C and A here in my solutions. All right, so let's color in C. All right, now let's talk about the endpoints on it. Now, it said less than or equal to, so it seems like you would do closed circles, but not on -2, right? Because -2 makes it undefined. So that one would be open, and this one would be closed. All right, now let's do part D. All right, so part D, that's numbers on the right side of 1 would be 2, 3, whatever. Okay, let's just do 2. I always try to pick the smaller number if I can. All right, so 2, all right, plug in 2. 2 plus 4 would be positive. Okay, 2 minus 1 would be positive. And then 2 plus 2 would be positive. Okay, that's supposed to be less than or equal to 0. Now, that's just a bunch of positive signs, so that's going to be positive. So is a positive less than or equal to 0? No. So D doesn't work. Now, so you see I have 2 intervals that are solutions and 2 intervals that were not. Okay, now let's write the answer in interval notation now. All right, go from left to right. Tell me here. Infinity to 4, bracket, all right, union -2 to 1, bracket. All right, number 50, let me think about that. What does number 50 look like? Like 50, 49, let me see if I had 49 on there. I had 47. Let me see if we can come back to it, okay? Because I definitely got to get to one here like this one, okay? All right, now, look at this one. You remember the first 2 steps that we mentioned? This is where this is really going to come in, okay? Because what? It has to be set to 0, and it has to be a single fraction, okay? Now, so how do we set it to 0 then first here? Yeah, just subtract the 2, no big deal. Okay, so be -2 is less than 0. Now, is that a single fraction? No. So how are we going to make that into a single fraction then? Common denominator, right? You actually have to take this and actually subtract it. And to subtract it, you have to get a common denominator. Now, there's only one denominator there, and so that denominator would be x plus 2. Oh, I'm sorry. Okay. Now, so let's see. When we go from here to here, nothing's changing, right? So can I just bring down x plus 1? All right. Now, I'm not going to bring down the negative 2, am I? Because what? The denominator on negative 2 is really like an understood 1. Okay. So what am I going to have to multiply here? I'm going to have to multiply this by x plus 3, right? So that would give me, it's negative, negative 2x minus 6. All right, now let's clean up that numerator. X minus 2x would be negative x, and then 1 minus 6 would be negative 5, okay, over x plus 3, and this is supposed to be less than 0, okay? Now, so from here, it's really not any different from the problems that we've done in the beginning, right? Okay, so it's really not anything new from this point. Now, what might throw you off a little bit is you can tell what one of the critical points from the denominator right there is going to be negative 3. But it's kind of hard to tell what makes the numerator 0 with all the negative signs and stuff. So, you know, it's you got what I'm saying? It's like really easy to see negative 3 in the denominator makes it 0. Okay? So what if I can't like mentally figure out what makes negative x minus 5 0? Yeah, just set it equal to 0 and see. Like, you know, go on the margin of your paper, like over here. So if I have negative x minus 5 equals 0, all right, what would we do then? We would add 5, and so we get negative x equals 5. So, yeah, divide by negative 1, and so x would be negative 5. So what makes this 0 right there? Negative 5, okay? So now, what are our critical points here? Right, negative 5 and negative 3, okay? Now, let's do this to make this one go faster, okay? Some of you do negative 6. That would be up the interval over here, right? And then some of you do what would be in between negative 4, and then some of you do a number over here, negative 2. I would use 0, but you can use negative 2. Okay. All right, y'all test them, and so y'all tell me if they work. Just pick one that I chose there. A decimal. So like negative 2.5. Okay. Does that kind of answer the question you were asking about? That you wanted me to do that other one? Okay, I'll do that other one in just a second. All right. Yeah. Yeah, I mean, that'd be, so, yeah, you can have fractions. All right. And probably what you want to do with fractions like that, on a number line, you probably don't want to think of them as improper. Think of them as a mixed form. Okay. All right. Now, so what about over here with negative 6? Did it work? All right. Well, let's see. If you put in negative 6, that would make that what? Positive 6 minus 5 would be a positive. Okay. And then it'd be a negative on the bottom. And so that would be a negative less than 0, so it works. Okay. All right. You got to be careful there because you got that negative, and that's going the opposite. Okay. Now, so let's test something in the middle there would be negative 4. Okay. So that would really make this one just say 4, right? So 4 minus 5 would be negative. Okay. And then negative 4 plus 3 would be a negative. Okay. So you got a positive is less than 0. That's not right, is it? Okay. All right. So I'm gonna go ahead and tell you 0 worked, didn't it? Okay. So this one over here gonna work. Now I didn't fill in my endpoints. This just says less than. So both of them are going to be open. Okay. Now let's pretend just a minute. Okay. All right. Let me just show you. All right, if you plugged in 0, you got it now? Okay. Yeah. So if you plugged in 0, you'd get a negative in the numerator, right? You get 0 minus 5. And then 0 plus 3 would be a positive. Okay? And so that will give you a negative. And a negative is less than 0. Now, let's pretend a second. What if it was equal to? Could you close both of them? You close negative 5, but you'd have to leave 3 open because it makes it undefined. Okay?